Welcome to section 3.5. I've titled this section Bayes Theorem, but really all this is about how to calculate conditional probabilities. And it actually can be fairly intuitive. So let's begin by thinking about an example. So the probability, let's suppose you're running a restaurant with a significant outdoor seating area. So maybe you're somewhere I used to live in Arizona between Phoenix and Tucson, and there's a lot of outdoor seating because the weather's beautiful most of the year, and when it's really hot, they can use these sprayers, right? So you might want to know if the average temperature is over 70 given in the course of a given week or in a given month. You might want to know the probability that on a given day that you'll have more than 100 customers if you know that the temperature is over 70 degrees. Yep. So the random variable that we're looking at is the number of customers we have, and we're conditioning it on the temperature, the outside temperature. So we can divide these two variables up into regions, right? So going up and downwards, the upper region of this figure represents probabilities of having more than 100 customers, whereas lower regions represent probabilities of having less than 100 customers. Similarly, on the left side, we're looking at probabilities that the temperature is less than 70 degrees, and on the right hand, the probabilities that the temperature is bigger than 70 degrees. So what we've got here is the blue region. This blue square right here is the probability that you'll have more than 100 customers, that's the upper part, and simultaneously the temperature is bigger than 70 degrees. This green region is simultaneously having fewer than 100 customers, but the temperature remains over 70 degrees. So together, the blue and the green region combined is the probability that the temperature is larger than 70 degrees. And the way this works, this conditional probability works, is if we already know that the temperature is over 70 degrees, we cut out the left region and just look at how big the blue region is, which is the probability that you'll have customers, more than 100 customers, relative to the blue plus the green region. And this is what Bayes tells us, Bayes' theorem tells us. We restrict our universe by cutting out the black version, and now we're looking at the blue region as being how often we have more than 100 customers, and the blue and the green region being our universe, which is what we know, which is that the temperature is bigger than 70 degrees. So let's look at this hypothetically with some numerical examples. Suppose that the probability that you simultaneously have more than 100 customers and the temperature is over 70 degrees is 35%. That's this blue region, right? This blue region is 35%. That's 35% of the entire figure, including the black part. Suppose we also know that the probability that we'll have fewer than 100 customers and simultaneously the temperature is 70 degrees is 12%. That's this green region here, and the 12% is relative to the entirety of the rectangle, including the black region. Right? So this blue is 35% of the whole thing. The green is 12% of the whole thing. So the blue plus the green is 47% of the whole thing. So obviously it looks different in my figure, but this is the probability that the temperature is bigger than 70 degrees based on this data. That's this region. This combined region is 47% of the whole region. So if these numbers were accurate, this black region should be a little bit more than half. So I didn't draw it right. So now what we want to know then is if we restrict our universe to the world where we already know that the probability is bigger than 70%, then this 47% essentially becomes our whole, and we want to know what portion of this whole the 35% is. Well, indeed, that is 35% divided by 47% is 74.5%. So this tells us based on these numbers, that the probability that you'll have more than 100 customers, given that we already know the temperature is over 70 degrees, is 74.5%. Formulaically, Bayes' theorem would tell us this. On the left side, which this is written vertically because I ran out of space, but on the left side, so up at the top, we have the probability that the number of customers is more than 100, given that the temperature is more than 70. And on the right side, we have this blue region from the figure, the probability that we have both conditions, divided by the blue and the green region, our universe we're restricting to, the given, the probability of t being bigger than 70. Now I realize that the difference between a conditional probability, which is what's up here at the top, and the numerator of this fraction, which is an and probability, may be a little bit murky. So in the next video, I'm going to talk a little bit about that to help you figure out how to figure out which is which.